Hello, my name is Jongwon and this is Asteroid project. For this project, my main contribution was extending the original Asteroid game to support a second player, multiple game modes, and a competitive scoring system. Specifically, I implemented player 2's movement, shooting mechanics, collision handling, scoring logic, and game mode selection between cooperation and competition. Here you can see both player 1 and player 2 on the screen. Player 2 is controlled using the WASD keys and fires bullets using the V key. Each player can move independently, rotate, shoot bullets, and interact with asteroids and enemy ships. The game supports two modes, cooperation mode, where both players work together to reach a target score, and competition mode, where the players compete to earn a higher score. The game ends either when both players are destroyed or when the win condition for the selected mode is met. In this part of the video, I will walk through the specific code that I added to the project and explain how it works in detail, including the logic and reasoning behind each design choice. This code initializes player 1 and player 2 objects, along with flame objects that visually follow each ship. The velocity is set to 0 initially, and the flame objects are positioned relative to the player's coordinates. Separating the visual effect from movement logic allows easier control of animations without affecting physics calculations. Each player has its own movement thread, allowing independent control without lag. Incremental velocity and rotation using velocity step and rotate step creates smooth movement rather than abrupt jumps. Movement calculation use trigonometry based on the current angle, enabling realistic directional movement. The inner loop stops if the player is destroyed, P2 died or P1 died, preventing further competition for dead players and saving resources. Input is handled via swings input map and action map, which toggles booleans instead of processing events directly. Movement thread with these booleans, keeping input responsive even when multiple threads run simultaneously. Bullets are created at the player's position with the same rotation as the ship. Storing bullets with timestamps allows time deletion, preventing memory bloat, and ensure consistent gameplay. Rotation locking ensures bullets visually shoot in the correct direction even if the player rotation immediately after firing. Bullets are moved frame by frame in a separate thread. Time-based expiration ensures bullets are removed after a certain duration, preventing infinite memory growth and potential array index errors. Collisions are detected using collision occurs. Depending on asteroid size, it may split or be destroyed. Scores vary by asteroid type, encouraging strategic shooting. In cooperation mode, scores are combined. In competition mode, scores remain independent. Game mode class handles drop-down input, decodes the mode, and applies rules for scoring and win condition accordingly. A dedicated thread continuously checks end conditions. If both players are destroyed, the game ends immediately. Otherwise, the game ends when the mode-specific win condition is met. Movement shooting, collision detection, and win-lose evaluation all run in independent thread. This design ensures smooth real-time gameplay without one system blocking another, and also allows each component to scale independently if needed. Overall, my contributions extended the original game to support multiplayer, structured scoring, mode-based logic, and multi-threaded performance, ensuring a smooth and strategic gameplay experience.